You know, when you think about an engineer's toolbox, you probably picture things like wrenches, circuit boards, maybe lines of code, right? But some of the most powerful tools an engineers use, well, they're not physical at all. They're the words we use to build our world, and sometimes to break it.
So let me ask you something. In a field that's all about high-powered machines and incredibly complex systems, what do you think is the single most dangerous tool an engineer could possibly use?
A poorly written sentence. And look, that might sound like a punchline, but it's really not. A single vague instruction, one misplaced decimal point, or a confusing report can lead to absolute catastrophe. This isn't just some theory. It's a problem the industry takes very, very seriously.
All right, check out this number, 40%. It's a huge figure, and it represents something absolutely critical in the world of engineering.
That is the potential drop in miscommunication errors when technical communication is crystal clear. We're talking about industry giants in India, like Tata and Mahindra, saying that precise language directly makes work safer and more efficient. So yeah, the stakes are incredibly high.
So what's the fix? Well, it's a very specific training program, a kind of blueprint for communication that's given to first-year engineering diploma students before they even get near a major project.
The whole course is called Communicative Language, and its goal isn't just about grammar or vocabulary. No, it's about taking that stuff you kind of know passively and turning it into an active, practical skill. It's about turning a student into a pro who communicates with total clarity. And this whole thing is built on 4 core skills. First, learning how to describe machines and processes with precision. Then, how to look at a complex scene and explain what's happening. Third, how to reflect on your own experiences to get better. And finally, how to translate technical info accurately.
All right, let's dig into how this actually works. We'll start with that very first skill. It all begins with the basics, describing a single machine, but with absolute precision.
Now, what's fascinating is the structure they have to follow. This is not creative writing, okay? It is a super rigid 8-step formula, and the order is everything. You start broad with an introduction, then you hit them with the hard data, the specifications. From there, you break the machine down into its parts and explain how it actually works. It's only after all of that that you talk about what it's used for and what its pros and cons. It's this perfect, logical flow that makes sure nothing gets missed.
And this right here? This says it all. It is good. What does that even mean to an engineer? Nothing. It's useless. But it offers plus or minus 0.5% accuracy. Now, that is a hard fact. That's a number you can rely on. A specification that prevents disaster. This is the level of detail we're talking about.
And believe me, this isn't just some classroom exercise. This exact skill is what people use every single day to write user manuals, service reports, and project proposals that keep huge companies like Bosch and L&T running.
Okay, so once you can describe a single object with that much detail, the training gets broader. The next level is learning to describe not just a thing, but a whole complex, moving situation. It's all about seeing the big picture.
So students get a new challenge. They're shown a picture, usually of something chaotic, like an accident or a super busy workshop, and they're just told, describe what you see. Listen to this little bit from a model answer. See how specific it is. Overturned two-wheeler, rider holding his arm. It's organized, moving from what's right in front to what's in the back, painting a clear, objective picture of what happened.
But here's the real ticker. This isn't a test to see if you're a good writer. This is training for one of the most serious documents an engineer could ever write, an official accident report. Being able to see and report just the facts, with no emotion or confusion, that's a critical, life-saving skill.
After that, the focus shifts inward, because great communication isn't just about describing the world out there. It's also about understanding and talking about your own process of learning and getting better. So students are actually taught to keep a diary. This entry from a first-year student, Priya, really captures it. It's not just about what she did, filing a piece of metal. It's about what she learned from doing it. That kind of reflection is what separates a good technician from a true professional.
And that brings us to the last crucial piece of this communication puzzle, something that's especially important in a place like Maharashtra's industrial sector, bridging the language gap. See, in a lot of these industrial workplaces, you have 3 languages all flying around at once. You've got English for all the technical manuals and global standards, then you've got Marathi, which is the official language for government stuff. And then there's Hindi, which is often what everyone's speaking on the workshop floor. A great engineer has to be fluent in all 3 worlds.
The real goal here is something called sense-for-sense translation. It's not about just swapping one word for another. It's about making sure the exact meaning and intention gets across perfectly, whether you're submitting an official government document or explaining a safety rule to your team. There is literally zero room for error.
So when you put all of these pieces together, the precision, the observation, the reflection, and the translation, you're not just getting a list of skills. You're actually building something way bigger. You're transforming a student who has the textbook knowledge into a competent professional. Someone who isn't just good at the technical stuff, but someone you can actually trust with the big responsibilities that depend entirely on clear communication.
So this is it. This is the engineer's other toolbox. Inside, you've got precision to stop mistakes before they happen. You've got observation for reporting the facts. You've got reflection for constant growth. And you've got translation to keep everyone connected and safe. These are the tools that build amazing careers and our entire world.
Which really just leaves you with one final thought. If this is the level of precision and structure you need just to describe a single tool correctly, what kind of communication does it take to build a whole city?